This is Gail Kovac for Gresham-Barlow School District. This is summer school, high school credit recovery, data reasoning, and learning target number 11. I can find various probabilities given a two-way table. So far, we've looked at quantitative variables only, that's answering in numbers. We've looked at univariate, that's one variable, and bivariate, that's two variables. Now we're looking at two variables with categorical data. So someone asks you a question and you answer as a category rather than a number. And in here, we are looking at whether or not someone is on the honor roll, and I believe that's for grade performance in school, and how much sleep you get, if you get 8.5 hours of sleep or you do not get 8.5 hours of sleep. So we're looking for if there's a connection between those two. So let's find some probabilities. The first one we want to find is the probability that a student is on the honor roll, that someone is randomly selected and they are on the honor roll. Don't even care about their sleep. We just want to know, how about honor roll? So first thing we're going to look at here is on the honor roll. We're going to look at just the totals here. So let's ignore the sleep stuff for now. We don't care about the sleep stuff. We're going to look just right here to the totals. So there are 130 students that were on the honor roll out of a total of 466. That gives no information about how much sleep they got, so that's a total of 130, and we're just going to leave this as a fraction. 130 out of the 466 said, yes, I am on the honor roll. And I'm going to write this number correctly. Here we go, 466. And we don't need to reduce fractions. We're just going to leave that exactly as it is. I prefer students don't reduce their fractions here because then I can see exactly where they got these numbers from and if they're correct or not. All right, so next question is, what is the probability that a student said they got 8.5 hours of sleep? So here's 8.5 hours of sleep. So we don't care whether or not they're on the honor roll. We're just going to be looking at total numbers, total hours of sleep. So I'm going to be ignoring these middle numbers again. I'm just going to be looking at sleep. So I have 94 people who responded that they get 8.5 hours of sleep out of 466 humans total. So this is going to be 94 out of 466. If you are looking for just probabilities of one variable or the other, then you're going to ignore these middle sections and look just to the totals on the side and on the bottom there. All right, so the next question we have is looking at a combination of the two. We want to know what's the probability if we randomly select one of these 466 humans that they are going to be on the honor roll and gets 8.5 hours of sleep. So we're looking for both of those things at the same time. So honor roll and 8.5 hours of sleep. So let's find the box that corresponds to on the honor roll and gets 8.5 hours of sleep. So here's on the honor roll. Here's gets 8.5 hours of sleep. That is a total of 60 people who said both of those things are true out of the total of 466 people. So we're going to leave that just as it is, 60 out of 466. The next one says, what is the probability that a randomly selected human would say that they are on the honor roll or they get 8.5 hours of sleep? Now the or is really important here. So if somebody is not on the honor roll, but they do get 8.5 hours of sleep, we want to include them because it says or. So just one or the other needs to be true. Similarly, if someone does not get 8.5 hours of sleep, but they are on the honor roll, we want to include them as well. So let's see all the people that we're going to include here. All right, it looks like I have all the people who are on the honor roll. These are the ones who say that they are going to get 8.5 hours of sleep. And these are the ones who say they are not. We don't care just as long as they're the ones who are on the honor roll. There's another group here that we are missing. we want to include all the people that have also said that they get 8.5 hours of sleep, whether or not they're on the honor roll. So here's 8.5 hours of sleep. These 60 are the ones that are on the honor roll. And here's the ones who are not on the honor roll. So we need to include 3 of these groups here. Now be careful not just to add the totals, because then you're going to be double counting the 60. Do you see how I circled that 60 twice? We're just going to add up the 3 boxes that I circled, because then you don't have to worry about double counting. So for these 3, I am going to add 60 just once, and 70 and 34, and that's going to get me my total that I'm looking for. Okay, so calculator, 60, 70, and 34 together, that is 164 people, 164 out of the 466 total, out of 466. All right, so the or includes more people. The and is a little bit more selective. It needs both of those constraints to be true to include them. The or just needs either one or the other to be true to include them. All right, so now we are going to take a look at some conditional probabilities. And conditional probabilities wants to look at a smaller subset out of this table, so not out of the 466. So let's see our first one here. It says, what is the probability a randomly selected person is on the honor roll given that we know that they get 8.5 hours of sleep? So in this case, we want to completely exclude the people who do not get 8.5 hours of sleep. So we're going to not look at this column whatsoever. We're going to be just looking at the column of people who get 8.5 hours of sleep, given 8.5 hours of sleep. We don't care about the other group. We're just looking at a subset of the total. All right, we want to know of the ones who get 8.5 hours of sleep, how many of them were on the honor roll? So here's the ones who were on the honor roll out of a total of 94 people who get 8.5 hours of sleep. So this is 60 out of 94 now instead, because we are excluding the does not get 8.5 hours of sleep group. This is called a conditional probability. And let's look at the last one here. The last one says, what's the probability that a randomly selected person gets 8.5 hours of sleep given that they are on the honor roll? Okay, so this is another conditional probability. We have a given. We know that this randomly selected person is on the honor roll. So I don't care about the group that was not on the honor roll. I'm just looking at the row of this table that were on the honor roll. So I don't care about this part of the table, not on the honor roll. They're not being included in this. So of this 130 people here who were on the honor roll, what's the probability that they get 8.5 hours of sleep? So here's the group that gets 8.5 hours of sleep out of the total of 130. Again, this is a subset of the table because there's a given constraint here. So I'm reducing the table. All right, so in this, there were 60 people, and that was out of 130 humans that were on the honor roll instead. So just remember, if you have a given, then you have to cover up part of your table. You have to constrict your table down. But all of the other ones should be out of the grand total of 466. You're looking for specific probabilities. Make sure that if it's and, then you're just looking at that very specific subset there. Or if it's an or, then you're including a few more people, and you got to watch out for that double counting.